we've got in a little relatively rare bit of history. It's a 2002 or 2003 Vox Korg era limited edition hand-wired AC30. This was the last new model made in the UK by Korg before they moved to overseas productions with the Custom Classic and the Custom and the Heritage and the hand-wired series. And this amp has got a single channel, high and low gain inputs, volume, treble bass top boost circuit, tone cut circuit, which is, what you find in the old ones, tremolo, added tremolo. It's not the original JMI tremolo like you'd find in the TBX. This is probably going to be more similar to Fender. We'll figure out how that works. It's got a tube-based reverb circuit. Again, I expect that'll be Fender-esque. And then a master volume. And we'll see how all this is implemented. It's got original filter caps. These need to be changed. It's 50-50, 50-50, 50-50. I'll talk to the owner about that as to whether we want to keep that or make it sound more like a real one. Now, the owner of this amp, I happen to know, has a real one. He has a JMI that I restored for him, and he has a TBX as well that I denoised for him. So he's got two great examples of the traditional JMI circuit, both the TBX and actual JMI. So this one can be a little bit different, but I'll talk to him about it. Let's look at some other things here. It's got this big tube shield here, so you don't burn your fingers when playing. It does nothing else really, but it makes it very difficult to change tubes. If this were my amp, I'd take this out. It's just these 4 screws. I will talk to the owner about that. On the rear, like the TBX, it's using a lot of the same parts as the TBX. It's got the foot switch control for tremolo and reverb. It's got speakers, output jacks, for single 8 ohm or two 16 ohm cabs and 8 ohm. So 2 8 ohm taps and a 16 ohm tap. Down here you got an HT fuse, a mains fuse, and an IC connector. It's using a lot of the same parts and construction as the TBX. That grounding there, I'm sure that can be improved. That's usually a big weakness in the TBX. This filter cap is not flush with the chassis like the others. Very crucial stuff to look at when you first get an amp in. You can see some leakage coming here out of the output cathode bypass cap. So since that cap is leaking, I suspect many or others may be. And this metal oxide looks a little bit shaggy, a little bit rough. That may have had too much heat on it. It's all turret board and hand wired. Lead-free solder. I can tell by the graininess of everything. And I'm surprised by one aspect of this. People think that turret board, hand wired, blah, 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 is automatically better than PCB. These are very, very large diameter stranded wires around these turrets, wrapped around. It's very solid, but as a result, there's almost no space between them. You have to be very, very careful that nothing wants to arc. If you're going to have turrets laid out this close together, you should really use 22 gauge wire. This is much thicker than that. If you're going to use a heavier gauge, say 20 or 18 gauge, you should really space the turrets out more from each other, because that is just so narrow. I wonder how many amps they had QC issues getting them out of the factory door just because one little bit of solder made a bridge here and there. Anyway, it's a combination of 0.5 watt and 1 watt carbon films, and all that's fine. It's got the Yellow axial caps, they're probably fine. The solder throughout looks like crap because it's lead free. Yeah. That'll be fun to rework if anything needs it. It's got silver micas, but they're the good ones, not the generic ones that like to leak. All the electrolytics need to be changed, because if this cap is leaking, the others are prone to it. Pretty straightforward stuff. It's got one carbon composite resistor there. Looks original. I'll figure out what it's doing in the circuit. Yeah. Let's see here. The original filter caps are ARS. They're not visibly bulging on the inside. This one has a bulge on the outside, but that may be plastic. Either way, this is 20 years old. But to protect the investment and to guarantee the best sound, it'd be good to replace all those. Looks like it's just a cross-line master volume. Now that will always be audible unless it's like 1,000, unless it's a 1 meg. I'll measure it to see. Maybe it's written on here. If it's a 500K, it's always audible. Yeah, 500K. So that's the spot where we might want to either put in a 1 meg pot so that when it's on 10, it's really out of the circuit, or maybe even replace this with a push-pull pot to really bypass the master as needed. Sorry about the clutter in the background. I've got so many amps going at once. So they're using CTS pots or equivalent. Look like CTS. I'll draw out bits of the circuit as necessary. It's no real mystery. Let's see. Work out the reverb driver. There's probably that here with a shared cathode. And there's like a shared cathode here. I'll figure out what's going on with that. So I got to at least work out the circuit to some degree to know what's going on. But step one is just to replace the filter caps. But before I can replace the filter caps, I need to have a pretty good overview of the circuit to know whether they're doing a ladder, like a Marshall, or whether it's a tree branch, like a true AC30, and if so, how they're handling it. My inclination for AC30s is to go much lower in filtering than this has. But like I said near the start of the video, the owner's got some real ones. This doesn't have to be a real AC30. And this was a very expensive hand-wired blah, 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 made in the UK, blah, 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 blah. I can tell just from looking at it that this would not have sounded like an AC30 in stock form. But it doesn't mean it sounds bad. It's AC30 adjacent. After poking around a little bit and taking some measurements, I have a better sense of things now. The various nodes are all using a tree branch circuit versus a laddered circuit for the filtering. So here's the screen node comes to here, and these are all the dropping resistors to different preamp stages. And there's one additional one here, this yellow wire with this 10 microfarad cap, and I'm not quite sure where it goes. That might be the very first stage. Let me take a measurement of that real quick. Yeah, that's the 10 microfarad filter node for the very first gain stage in the amp. Complication on that 10 microfarad. There are very few axial electrolytics being made in these values. The F&T is a 16 microfarad. It's a little bit longer than the 10 that they make, but not by much. 10 microfarad F&T will be too long for that. And while I could use a radial there normally. This is not a 10 microfarad, but it's about the same size as one. There's a wire going right here beneath. That's the screen supply, so I don't want to have a chance of arcing. So I'll look at my options on that. There's an MOD 10 microfarad cap that might work. Axial. I need to check its specs. If I need to, I'll find a different place on the physical place on the board to mount that. I'll see what our options are. But, these are considerations. The caps that were available on the market in 2002 are not always available 20 years later. And what a shock it is that's been 20 years, because sometimes I blink and that's a week or two ago. Other than that, the circuit is fairly traditional. Comes into just one stage compared to just one triode, whereas the original had two triodes of 1, 2 being used for normal and top boost. Let me confirm real quick that they made the correction on the cathode bias for that. Pretty close. They went with the 2.7K rather than the 3K that would be precise. I don't think anyone's going to really hear a difference there. And then it goes to a next gain stage with a cathode follower for the tone stack. That's split across two different tubes here rather than across one, but that's fine. Tone stack's fairly standard, with the exception that they have this ground and the wiper connected on the base pot. That's a later thing that Korg liked to do. The originals would have not had that connection there. And where is it? So right here, this 10K resistor here would be across the white and black wires you see here. Changes the bass response. I'll talk to the owner about that. I haven't sussed out the reverb and tremolo stuff other than I know it's there. If it's working, I won't have to touch it. If it's not working, then I'll figure out why. I'm more interested in the core stuff. Got 47, 47 on the inputs of the phase inverter, 100 and 100 on the outputs. And that's probably the cap for the cut circuit. These are the dropping resistors between stages. This is the output cathode bias resistor. Once I have a good cap here, I'll see how it's biased. It's got 100 ohm screen grids, some 1 or 2 watts there. That's not going to give very long life for modern EL84s, so I'll probably bump those up a bit. The screen grids are here from pin 8 to pin 2. Some EL84s use pin 8 for internal connection. Not that many, but in general, it's not the best way to design things, because you could get some old tubes from the 50s or 60s, and that's being used for an internal connection, and things go amiss. But 1.5K, 100 ohm, that's straight JMI, including the mistakes. This resistor measures okay cold, but given how shaggy it looks, I just don't trust it. So that's a 22K resistor, easy to change out. And some different things will need to be moved around on the ground. Just Korg from this era, which was the same thing as Marshall from this era. This is from the mines that brought you the JCM 800s and the after 83 as well. Just some common little quirks and minor mistakes that are easy to change. Overall, this doesn't look very, very scary. I do want to talk to the owner about some filter values, though.